Have you ever wondered how everything we see in the universe emerged from a single point? What if I told you that the Big Bang might not be the beginning at all? Today, we're diving deep into a revolutionary idea that could change our understanding of the cosmos forever. Buckle up, because we're about to explore the concept of a mirror universe and what it means for the very fabric of reality. So, welcome back to Calum. Today we have a special treat for you. We're going to unpack some mind-bending theories from the world of cosmology, inspired by the brilliant minds of physicists like Stephen Hawking and Neil Turok. Together, we'll explore the mysteries of the universe, the nature of time, and how a minimalist approach could hold the key to understanding it all. Settle in, and let's get started. First up, let's talk about the Big Bang. It's often described as the moment everything began, but what if that's not entirely accurate? Stephen Hawking proposed that the universe could emerge from a singularity, a point where space and time as we know them cease to exist. But this raises a fundamental question. What came before the Big Bang? Hawking suggested that if we trace back time using imaginary numbers, we can avoid hitting that singularity altogether. Instead of a sharp tip, we get a smooth transition, a rounded cone representing time. This idea opens up a fascinating possibility. What if there's no beginning at all? Just a boundary condition that allows for an eternal universe. Now let's dive into the concept of the mirror universe. Imagine taking our universe and reflecting it across the Big Bang. What if everything we see today has a counterpart on the other side of that boundary? This idea suggests that before the Big Bang, there was another universe, one that mirrors our own. This concept builds on Hawking's work, but takes it in a fascinating new direction. Instead of just having a smooth boundary at the Big Bang, what if we have a complete mirror image of our universe on the other side? Think of it like looking at yourself in a mirror. Everything is flipped, but the fundamental laws remain the same. In this case, the mirror isn't just reflecting space, but time as well. Neil Turok has been working on this theory, proposing that by treating the Big Bang as a boundary condition rather than a singular event, we can create a more coherent picture of cosmic evolution. This approach not only simplifies our understanding, but also aligns with observations of cosmic microwave background radiation. What makes this idea particularly elegant is how it solves several cosmic mysteries at once. For example, it naturally explains why our universe appears so uniform on large scales. It's because we're seeing the reflection of a universe that evolved in the same way. It also provides a beautiful symmetry to the cosmos, where the laws of physics remain consistent across the Big Bang boundary. But here's where it gets even more interesting. In this mirror universe picture, particles and their mirror counterparts are connected through what physicists call CPT symmetry, where C stands for charge, P for parity or spatial reflection, and T for time. This symmetry is one of the most fundamental principles in physics, and the mirror universe theory suggests it might be the key to understanding the very beginning of our universe. Next, let's discuss minimalism in physics. In recent years, many physicists have added layers upon layers of complexity to theories like string theory and inflation. But Turok argues for a return to simplicity, using only the known laws of physics to explain everything we observe. By focusing on what we already understand, Turok believes we can explain phenomena like dark matter and cosmic fluctuations without introducing new particles or forces. This minimalist approach not only makes predictions more reliable, but also aligns with the beauty and elegance that many physicists strive for. What's particularly fascinating about this minimalist approach is how it challenges the trend in modern physics. For decades, when physicists encountered new phenomena, their first instinct was to add new particles or forces to explain them. But Turok's work suggests that maybe we already have all the pieces we need. Instead of adding complexity, we might just need to look at the existing laws of physics in a new way. This philosophy has led to some remarkable insights. For example, Turok and his colleagues have shown that by treating the Big Bang as a boundary condition, rather than adding new physics, we can naturally explain why our universe appears so uniform on large scales. It's like solving a puzzle by rearranging the pieces we already have, rather than looking for missing pieces. So, what does all this mean for the future? If Turok's theories hold true, we could be on the brink of groundbreaking discoveries. For instance, gravitational waves generated during the Big Bang could provide us with direct evidence of this mirror universe. Imagine building a gravitational wave detector sensitive enough to capture these signals. In just a few years, advancements in technology could allow us to peer back into the very moments after the Big Bang and validate or challenge these theories. The key to this discovery lies in millimeter-wave gravitational waves. These waves would have been generated at the Big Bang when the temperature was extremely high, about 10 to the power of 19 GeV, or what physicists call the Planck temperature. At this point, all gravitational degrees of freedom would have been excited, creating a thermal bath of gravitational waves. As the universe expanded, these waves would have stretched to millimeter wavelengths today. Building a detector for these waves is an incredible engineering challenge. We need a device about 1 billion times more sensitive than current gravitational wave detectors like LIGO. But unlike LIGO, which is kilometers long, this new detector would be just millimeters in size. Scientists are already working on prototypes using cutting-edge quantum technologies and superconducting materials. The payoff could be enormous. If we succeed, we would literally be able to look at the Big Bang singularity itself. These waves would have traveled through the early universe without being scattered or absorbed, giving us a direct window into the very beginning of everything. It's like having a time machine that can take us back to the first moments of the universe. In summary, the exploration of our universe is filled with profound mysteries and exciting possibilities. The idea of a mirror universe challenges our understanding of time and existence, while advocating for a minimalist approach could lead us to answers we've been seeking for centuries. So, what do you think? Is there a mirror image of our universe waiting to be discovered? Let us know your thoughts in the comments below. And if you enjoyed this journey through cosmology, don't forget to like this video and subscribe for more content. Until next time, keep looking up at the stars.